Hello everyone. I'm going to talk about the streaming and Apache Storm. Let's start with big data. We all know right now is a big data era. The application of big data cover healthcare, finance, retail, and media and entertainment, e-commerce, etc. And by analyzing the massive amounts of data, some meaningful information can be generated, such as more efficient medical treatment. When we talk about big data, what's the difference from the regular data? Although the answer to this question cannot be can universally defined, and there are a number of characteristics that define big data. The main characteristics are volume and velocity, variety, veracity, and value. The volume of big data is the size of the data sets that need to be analyzed and processed, which are now frequently larger than terabytes and petabytes. This means that the data sets in big data are too large to process with a regular laptop or desktop. For example, our credit card transactions on a day within Europe is an example of a high-volume data set. The velocity refers to the speed with which data is generated. High velocity data is generated with such a base that it requires distinct or distributed processing technologies. An example of a data that is generated with high velocity would be the Twitter message or the Facebook posts. Variety. The big data comes from a great variety of sources, and generally is one out of three types, like structured, semi-structured, and unstructured data. The variety in data types frequently requires distinct processing capabilities and special algorithms. An example of high variety data sets would be the CCTV, audio, and video files that are generated at various locations in a city. The veracity refers to the quality of the data that is being analyzed. High veracity data has many records that are valuable to analyze and that contribute in a meaningful way to the overall results. Low veracity data, on the other hand, contains a high percentage of meaningless data. The non-valuable in these data sets is referred to as a noise. And an example of a high veracity data set would be data from a medical experiment or trial. And the last one is the value. The value density of data is relatively low. So how to combine business logic and use powerful machine algorithms to mine data value is the most important problem in the big data era. Data can be divided to unbounded data and bounded data. The unbounded data is an ever-growing unlimited data set, also called streaming data. The bounded data is a limited data set. Extracting a part of unbounded data according to the time window will produce the bounded data. We can say the bounded data can be regarded as a subset of the unbounded data. This time we mainly discuss unbounded data, which is streaming data. So we need streaming processing. Streaming processing is different from batch processing. The stream processing is real-time processing, and while the batch processing is delayed processing. Let's say the stream processing. A stream processor acts on an unbounded stream of data instead of a batch of data. The stream system needs to receive and process a series of continuously changing data. The features of streaming processing is high throughput and low latency. The response time required for stream processing should be calculated in milliseconds or microseconds. And the reason for the fast stream processing speed is the data has been analyzed before it reached the disk. So it's the speed is very fast. And move ahead. Let's say the scenarios of the stream processing. There are many scenarios where stream processing is needed, such as financial applications, network monitoring, social network analysis, like Twitter or Facebook, and sentiment analysis on tweets, log processing. For the log processing, we use Storm to check each log information and save the message that meet the matching rulers to the database. And e-commerce product recommendation. The backend needs to maintain the interests of each user, mainly based on the user's history, behavior, queries, clicks, and other informations. There are many real-time data which can be processed by Storm, and accurate product recommendations and placements can be made on this basis advertising. That's scenarios. So far, there are some stream processing frameworks like Apache Storm and Apache Kafka and Apache Samla and the Apache Flink. This time we focus on Apache Storm. And the Storm is a distributed and real-time computational framework that makes processing unbounded stream of data easier. The stream processing tool runs indefinitely, listening to a stream of data, doing something anytime it receives data from the stream. Now let's take a closer look at the components of Apache Storm. The main components are topology, tables, and stream, and spout, and boat. And this picture is a simple topology. The topology is a graph of computation, where the nodes represent some individual computations, and the edges represent the data being passed between nodes. And the table is the main data structure in Storm. It is a list of ordered elements. Nodes in the topology send data between one another in the form of tables. And the stream is an unbounded sequence of tables between two nodes in the topology. About the spots. The spot is the source of a stream in the topology, and it reads data from an external data source and emit turbs into the topology. So the bot accepts a turb from its input stream, performs some computation or transformation, filtering, aggregation, or a join, and then optionally emit a new tabs. So when executed, the topology is defined as a set of processing entities over a set of computations results. Typically the cluster, and the parallelism is achieved in Storm by running multiple nodes of the same spot or boats. So there is a question: how tables are routed to the various boats, and we need to introduce the function of stream grouping. There are 7 built-in possibilities. The most interesting are suffer grouping, which means the tables are randomly distributed, and the field grouping, which means the stream is partitioned according to a table attribute. The tables with the same attribute will be scheduled to the same boat. And the third one is OR grouping. OR grouping means the tables are replicated to all boats. And the direct grouping, which means the producer decides the destination boats. And the global grouping means all the tables go to the same boat. Also, the user has the possibility of implementing their own grouping through the custom stream grouping interface. So when executed, we need to submit the topology to Storm cluster. Let's say the architecture of Storm cluster, and there are two types of nodes on the Storm cluster: master nodes and work nodes. And the master node runs a daemon called Nimble. The Nimble is responsible for distributing code to the cluster, assign tasks to machines, and monitoring failures. The work node runs a daemon called Supervisor. The supervisor monitors the work assigned to this machine and start or stop the work process when necessary based on the Nimble distribution. So, each work process executes a subset of the topology, and a running topology is composed of multiple work processes spanning multiple machines. And our coordination of Nimbles and supervisors is done by the zookeeper cluster. In addition, the Nimbles and the supervisors daemons fail quickly and are stateless, and all states are stored in zookeeper or local disks. This means that you can kill Nimbles or supervisors, and they will start again as if nothing happened. This design makes the Storm cluster incredibly stable. And let's take a closer look at the work nodes. The work process is will perform tasks related to a specific topology. And the executor is a thread created by a worker execute one or more tasks. The task performs the actual data processing, like a spot or boat. Finally, let's take an example. Word frequency statistics. Statistics in big data. This is first we need a construct topology, and this is a topology. There are 4 nodes and 1 spot and 3 boats. The the spot reads a line of text and send it downstream, and the fourth bot divides the sentence into words, obtains a line of text from the data sent by spot, then divide it into words and send each word downstream, like this. And the word counting bot receives the words issued by the word segmentation bot, and counts the number of occurrences of each word, and then sends the word and its frequency as a data unit to the downstream. And the last bot is a printer bot. The bot output as a result receives the data unit sent by the counting bot, takes out the words and their times for summary, and finally outputs the statistical results. That's the topology. When we create the topology object, connect the spot to each bot, and then we can submit the topology to Storm cluster for execution. That's it. Thank you guys. Thank you for your listening. And next time I will share the implementation of encryption in Storm.